All right, well, welcome everyone this evening. My name is Chris Bachman. I'm the chair of SAE SoCal. That's what I do in the evenings with the rest of the SAE SoCal board, which I'll talk a little bit about. But during the day, I'm the chair of the mechanical engineering department at Cal State LA. So shout out for CSU Fullerton for coming out today. Like, way to rep SAE SoCal, FSAE. So first, I'll just talk a little bit about the section. So excuse me if, of course, Dean had a good hand in the creation of these slides. So shout out to you. But I mean, I don't know. I think we have a lot to brag about in Southern California. So there's countless stories about awesome vehicles and mobility and racing in Southern California. And so every one of these vehicles was actually designed in Southern California, and not only on land, but even now, this is really becoming kind of a aerospace and defense hub. So not only those vehicles, but these vehicles have all been made in Southern California. And so we're trying to continue to grow our SAE chapter in this area with professionals from all of these areas. And so the folks that are doing that, myself, John Steiner's here, he's our comms lead, Dean's our membership lead, and then there's another handful of other folks that run the section and put together these like kind of lecture series or meetings. And so today even just came about because Joe came to us and said, hey, have you ever done a talk on quality? And we said, no, we haven't. Like, why don't you step up and do it? So that's how these things typically come about. So if you're interested in a topic and you want to see a topic here, come and talk to us afterwards. We'll do our best to make that happen. So the section in Southern California is actually one of the most active. I mean, us in Detroit, and I think we actually do a lot better with our connecting with all of our student groups down here. But so these are all of the events that we've done so far this year. In addition to, a lot of us go out to the Baja and Formula races that are all around. So some of the upcoming SAE SoCal events. So I'll do a couple of slides on the first couple. So we're gonna have a couple more presentations here, but we're also gonna have, for like Cal State Fullerton, we're gonna have our big 38th annual SAE SoCal workshop, try and help the SoCal teams really be successful. And so if people have ideas for, what are topics that they would like to present to, Formula students and Baja students, we're all ears and we're always looking for volunteers for that event. Also hosted here. So the next upcoming event is about hydrogen power and using hydrogen not only in fuel cells, which is what most people know them for, but can we also use these in combustion engines? So this will be our July meeting. And then we're going to have a really cool meeting bringing in Southern California engineers who've worked in the F1 space right after that. So I'm really looking forward to that one. So a quick shout out to all of our student chapters. So Dean, how many student chapters do we have now in this area? 17, 8?
Active, 4 in the formation, and hopefully 4 more. So more than any other place in the country.
Yeah, and I'll tell you, I spend my spring and summer meeting with students coming out of high school from all over LA, and you ask them like, oh, why are you interested to work in engineering? The answer still inevitably every time is, oh, I think cars are pretty cool, and I want to work with cars here and there, right? And so it's like, it's immediately on the, even more so than rockets or aerospace, cars still drive a lot of passion for tinkering, and so it's a great space to be in. So so shout out to all of our student chapters. Remember that. So Fullerton, I'm not sure if you are in this boat or not, but so in SAE there's both all of the university design series, and so you have like Baja, Formula, SAE Aero. You also can form your own SAE chapter, and that's pretty cool because the money of your part of the money that you pay for your dues comes back to your students, and you guys can use it for whatever you want related to SAE. You can also invite a bunch of different people to come and give talks at your school. So like I invited Milliken out to come give a talk here at SAE as a part of the Industrial Lecture Series for Cal State LA one time. So there's all the people you can find online, and there's even more if you start to poke around, of people you can bring in to help you with your design and build. So I also want to shout out, we put most of our meetings up on our YouTube channel, so there's a good repository of stuff there. And so definitely, check out our LinkedIn and some of our YouTube. That's where we're most active. And so with this, I want to hand it over to Russ just to plug the Motor Press Guild really quick. So let's give him a round of applause.
No mics? Was it working? Hello?
Right.
Hello?
To be honest with you, maybe I'm using it wrong.
I'll just project. Hi everybody, my name is Russell Datz. I'm a board member at the Motor Press Guild, which is a 42-year-old organization representing automotive journalists and now content creators, influencers, and other people who report on the automotive industry. Dean, thank you so much for giving me a couple of minutes to talk about it here a little bit. I know this is an engineering conference. I'm way outbrained here, so I'm just going to talk about a little bit of a creative side. I do know one engineering joke, though. Can I tell it? It's not offensive, I don't think. All right. Some people say the glass is too big. Some say it's too small. Engineers will say no. Some look at the world. The glass is half full, where it's glass is half empty. Engineer says it's twice as big as it needs to be. Right. So, yeah. I don't know. That's good. My attempt at humor. So, maybe my career as a comic is dead on arrival. Anyway. So I spent about 25, 30 years. I started as a journalist way back in the 1900s with a television show called Motor Week. You might be familiar with it. It's on Maryland Public Television, PBS, et cetera, et cetera. I was the young guy driving the cars for the camera and shifting the gears and moving the seats and all that kind of stuff. The body, as they called it. And that set me on a path for a great career in the automotive industry. First writing about them or making television about them, and then moving over to the PR side. And I did that because I wanted to be more upstream to the information, right? It was great to kind of be at the end of the river when it led out into the sea, and all the engineering had been done, all the marketing had been done, all the product design, and us journalists got to crap on it, and you work with some engineers, and it's really exciting to do that because then you understand the parameters that they were given to work within, right, to bring a product to market. But I wanted to be more upstream. I wanted to be with those engineers. I wanted to be with the companies that help make those decisions and decide, hey, we need a 5-passenger SUV in the E segment or whatever it might be, and it's got to come out at this price, and it's got to do this, that, and the other thing, and we got to, by tomorrow we got to do this, and for $30,000. That's a heck of a challenge. And if you're into cars and you're writing about them, you may have noticed that these days there's more ways than ever to learn about them. It's not just television and radio and the newspaper anymore. Does anybody know what a newspaper is anymore? Is that still a thing? I don't know. But there's something for everybody, right? And what the channels have in common is they have an audience that's looking for timely, relevant, accurate news and information on the products that they love and the products that engineers spend thousands of hours and $1 billion developing. Only to have, a 30-second clip on Instagram talk about, whatever cup holder or small little feature that nobody even thought about in the engineering. Well, somebody did, obviously. They made the cup holder, right? There was somebody at the company's very proud of the cup holder that they engineered for this car. And if you've actually seen some cup holders from cars in the 90s, I specifically remember Mercedes had one that you press the button and this articulated, hydraulically sprung arm came up. There was like a 3-axis thing, and it boop, and you'd fit a can of Coke in it, and then you'd press the same button and it would reverse the thing back into the thing. Very impressive. If it broke, you were screwed, but it was fun to watch while it was there. And every member of the Motor Press Guild was there to see it and write about it and talk about it. It's an organization that can help aspiring journalists, writers, video producers, radio and podcast hosts, and anybody else who wants to share information about their favorite subject, meet other like-minded people and understand more about how to be successful on those channels. And even meet other engineers, other journalists who write about engineering. How many people here know Engineering Explained, the channel, right? So Jason Fensky, right? I've worked with Jason for a long time. When he was first getting his start, he was an engineer that decided, I'm gonna talk about engineering instead of actually engineering. Went to school, the whole thing, and he's hugely successful now. And what he did is he made it fun to watch. He made engineering an entertaining kind of thing. He didn't talk formulas. I mean, he does, but in a way that most people can understand and appreciate, which is great. And those are the kinds of people who are in the Motor Press Guild. So I would encourage you, if you have any interest at all in creating content, writing about engineering, if you've got your own ideas for what you want to do with your engineering training, whether it's online or somewhere else or with a company, maybe it's even just your own brand you want to promote, the MPG Motor Press Guild can help. So go to motorpressguild.org, spelled just like it sounds, Motor Press Guild, and check it out and sign up, become a member. We'd love to have you. So that's it. Thank you very much. Appreciate it.
I was going to say, I think newspapers are sadly slowly declining, but for me, the podcast is my new newspaper, and I've always, I mean, how many people here have listened to someone like Dean say, oh, there's this like race car driver, and he could come into the area, and of course you know them, right? And you're like, who? Like, I've never heard of this person. Like, I don't know, every old racer knows way more than I do about them, but I would love to have a podcast talking about all the old race car drivers coming out of Southern California. I'd sit there on my 710, sitting in traffic for an hour, you know, digesting that content away. Anyways, so I'll look forward to the Motor Press Guild podcast featuring Russ every week.
It's in the works.
Love it. Okay, so first I would also like to thank, I mean, this museum, every time I come, I see a new incredible car. So maybe we just thank the Lions Automobilia Museum first for like hosting us here today. It's such a hidden gem here. Like, so, you know, if you have, you know, gatherings or meetings, you know, reach out to us or Lana here about hosting something here, because it's such a cool space and I would love to see it get used more. So, okay, without further ado, I want to introduce Joe Zhang, one of our star students coming out of the SAE programs out of Southern California at University of California, Irvine. So one of our anteaters, an awesome school. They're one of the only schools in Southern California that does Aero, Formula IC, Formula EV, and Baja. They run the full SAE gamut. They should get a prize for that. I almost think. And then Joe has now worked in several OEMs, including like Tesla, and is now working in the aftermarket area, working in wheels. And so I'm definitely interested to learn more about quality, since I'm in the academic area where we build one of everything ever, and so we don't get to be exposed to this as much. But anyways, let's give it a round of applause for Joe.
All right. Good evening, everyone. Thank you for having me, and huge thank you to the SAE Southern California section for putting this event together. And a special thanks to Dean Case. You know, many years ago, I met Dean Case at a career event held by SAE SoCal. You know, it's truly amazing to look back and see how that one opportunity helped and lead me to where I am today. That is exactly why I'm here today, to pay it forward. And I deeply appreciate the opportunity to speak with you all. All right, before we start, I just want to give a shout out to this amazing venue, right? Just by looking at these cars, you can see how much the automotive industry has evolved over the years, right? With generations of engineers, hardworking engineers putting their time and effort to improve the process. It is incredible to feel like in this venue and to see and be part of this to move it forward. right. Okay, first, I want to properly introduce myself. My name is Zhang. I'm currently a quality engineer and sit on the product safety committee for Hoonigan and Wheel Pros. But before I joined Hoonigan, I was like many of the students here today. I was on the Formula SAE team. I was part of UC Irvine's internal combustion team and as a drivetrain engineer. Then I went to get my master's degree from University of Michigan. Go blue. And after that, I spent some time as a quality control engineer, an intern at the Tesla Gigafactory in Nevada, mostly doing product quality control on Model 3 and Model Y battery module production. All right. Before we start, I do want to see a raise of hand. How many of you are on the Formula SAE team right now? Okay, we got a couple. And how many of you are currently in the engineering field or work as a quality control professional? That's good, that's good. All right, great. This is exactly what I like to see. I especially made this presentation to help both groups feel helpful. And yeah, so for those students on the Formula SAE team today, I will share some of my thoughts on the gap between building your Formula SAE car and the OEM mass production. When you transition into industry, automotive industry, the game completely changes. The challenge is no longer about building one perfect part or a part that simply works. It's about building tens of thousands of parts per day across multiple shifts, different material batches, while still remaining profitable. For someone like myself, making that jump from single prototype to mass production required a complete shift on how I wield quality. And for those who are in the engineering field or QC, I want to share some of my insights on the latest technologies that brings both opportunities and challenges, and how proper quality control can mitigate these challenges in our fast-changing supply chain environment. I hope both groups can benefit from this talk, and in the end, we'll have some discussions. Okay? All right. The evolution of quality control. Quality engineering, like many engineering practices out there, is the art of balancing and trade-offs. Historically speaking, automotive quality control is just treated as a final checkpoint, a simple pass or fail, right? If a part failed, it just goes into the scrap bin. But modern quality engineering has evolved a lot. It's no longer just a checkpoint. It has become a core design strategy. If you look at the logic behind detection versus prevention, you'll quickly realize if you're only relying on end-of-the-line detection, it puts you in a massive financial risk. Why is that? The amount of the loss you have to bear completely depends on how soon you find out there's a quality issue. And I can tell you, if you run your quality control like that, by the time you identify these issues, it's already too late. If your quality control acts as a final toll booth, right? A failed product means all the time, material, labor, machine tooling wear, and opportunity cost go straight down the drain. Many in this room might know this. This is one of the reasons why Tesla almost went bankrupt before the Model 3 product delivery. Just like many startup companies out there, Tesla heavily relied on end-of-the-line inspections to catch defects rather than embedding quality gates throughout the production. This very reason leads to a terrible delivery rate, because how many cars you can deliver per day no longer depends on the actual output of your factory. It's limited by how many cars you can rework per day. As quality engineers, we're constantly managing the iron triangle: cost, time, and quality. You can't just man the zero defect at the end of the line without blowing up your production time and budget, right? This is why modern quality engineering breaks down the whole production process by embedding preventative checks and strategic detection points between each flow steps. This way, you're not only mitigating the risk, you're also lowering the overall cost on rework and scrap. This ultimately guarantees the quality of your final product. I think everyone in this room can agree that we're at a very troubled time regarding supply chains, right? We have high tariffs. We have global conflicts. Just a couple years ago, we have to survive a global pandemic. I cannot think of any time in history that's as challenging as today. Many companies like mine are forced to transition their supply chains to other countries to mitigate the risk. I can't say when or how the global environment is going to shift, but one thing I can tell you is no matter what decision your company makes, proper quality engineering brings stability to your turbulence and acts as the backbone of your company's overall financial. All right. I want to take a moment to share something very important today, especially for the students teams that are here. I actually just came back as a technical inspector from Formula SAE electric competition in Michigan last week. When I was doing technical inspection, I talked to many students there. I found something very interesting. Almost no one wants to work in the production or manufacturing environment anymore. When you're in school or in the Formula SAE team, there's a very obvious hierarchy on what's considered as a cool job. Everyone wants to become a design engineer these days. You want to run FEA, optimize your drivetrain, shape the aero, or shave off a few pounds here and there in the components. Very few students go to engineering school these days dreaming about, oh, I want to work in the production line doing quality control. Right? I get it. It just doesn't sound a very interesting gig. Nobody puts poster or production flow map on their bedroom wall, right? Sorry. But I do want to say, this is almost a very dangerous phenomenon that happens within the students groups, that they obsess over pure design and ignore the manufacturing and quality control. What's going to happen is you're going to end up with a very brilliant CAD model that is almost useless in the real world. When I was doing tech inspection last week, I saw something very interesting. I saw something that I normally wouldn't expect to see at a Formula SAE event. The University of Michigan's team installed AI-generated control arm that's completely designed by AI and 3D printed using 3D printed metal. This is something you only see on like very limited production hypercars, like the McLaren W1. Anyone here knows that car, right? One of the sell marketing on that vehicle is they have AI design control arms on the vehicle, right? On paper, right? If you see that some students team designed that, it's cool. It's really cool to see. So I want to spend some time explaining how exactly the process is, right? When you're using AI models to design something, the first thing you input all your parameters, right? Your loads, material, and clearance space is needed into an AI algorithm. The AI simulates millions of times probably in the back end and create these organically shaped, highly optimized components to achieve the minimum weight with the highest stiffness or performance. But just because of these organic shapes, it's almost impossible to manufacture. So the only solution is to 3D print them. I know it's on paper, it sounds amazing that a student team use these like latest technology into their design. And I honestly love to see that. But I have to say, this is a very classical example that what looks perfect on paper and very hard to achieve in mass production. Why is that? Right? So this 3D printing process, what we call it SLM, selective limited melting, is known for bad fatigue life. Meaning it handles static load just fine. If you have constantly changing loads, repeating loads, it doesn't handle very good. Why is that? Just like the name says, the process involves melting metal powder layer by layer using laser lights. This process creates a green direction. The material is very strong in one direction between the in each single layer, but the weak point is actually between the layers. In this case of surviving a race weekend, sure, the part might just hold up fine. But on a mass production vehicle, you will face a nightmare of warranty cases. Also, microporosity and lack of fusion is extremely hard to detect on these AI-generated shapes. You cannot get a good ultrasonic feedback from those geometries. So your quality control is useless in that case. I hope this example tells everyone never buy a McLaren W1. Okay. All right. All jokes aside, this very example tells us the gap between the mindset of building a race car for surviving a race weekend and building a car that needs to survive on the road for 10, 20 years minimum. Now let's switch gear. I want to use wheels as an easier to understand example. If you design a high performance wheel that hits all the check marks on weight, stiffness, everything's perfect on paper, right? But the geometry makes it impossible to cast without severe porosity. You haven't engineered a very good part. You just engineered a very expensive paperweight. The best design engineers I work with are not the ones who know the most complex CAD commands. They're the ones who practice design for quality. They understand that if a part cannot be consistently manufactured in the factory and has to be easily inspected, it's essentially a field design. So if you want to become a top-tier design engineer, you really need to bake quality into your blueprints. And here are the 3 pillars of design for quality. First, stop defaulting to tight tolerances. Every tight tolerances exponentially increase the cost and time of your production. A good designer knows exactly which mating surface require precision and which surfaces can be opened up to save money and reduce scrap. I learned this lesson firsthand at Tesla. I was given a very urgent task of redesigning a components for the manufacturing equipment that kept failing because some material fatigue failure. I had to fix it once and for all. And I quickly realized only if you obsess with over-constraining your design, that will only slow down the turnaround in manufacturing. And second is design for manufacturability and inspection. If you design an internal radius that's completely hidden, ask yourself this: how's your quality engineer supposed to measure it? If we can get a caliper, a micrometer, or CMM to probe it, we can't guarantee the part is made correctly. So the lesson is simple. Don't just think about how the parts fit into assembly. Think about how metrology tools fit onto the part. Lastly, understand the manufacturing process. Let me use wheels as an example here again. If you cannot design a great wheel, if you don't understand what's the difference between low pressure casting, flow forming, and forging, you need to know exactly how the material flows, where it cools first, where the stress concentrates normally naturally occur, and then you can design for it. So spend some time on the production floor. The best thing a design engineer can do is to watch how the parts actually get made, and more importantly, watch how they fail. All right. Last but not least, I want to spend some time talking about the latest and probably the more controversial topic in this industry right now, AI. To understand the improvement opportunity that AI brings, I want to use this project I worked on during my Tesla days as an example. The project involved integrating an AI detection system into the production line. And the vision-based model was designed to detect different types of quality defects and make decisions whether accepted or rejected. This is installed for the module cooling tube installation process. Previously, this task has to be done by a person sitting in front of a computer, hitting approve or reject thousands of times a day. As you can imagine, that's not a very fun job, first of all. And second of all, when the fatigue sets in or someone distracts you, there's a very real chance you're misapproving or misrejecting a part. But since these components directly links to the cooling of the module, a failure like this can directly impact the overall safety of your vehicle or the user, right? So to bridge this gap between the human error and to have absolute process control, we decided to use AI vision detection to replace this error-prone human method. Eventually, we achieved 100% accuracy, but I can tell you it was not a smooth process. First, training the model is always the hardest part. Just like any other AI models out there, the results, good or bad, entirely depends on the data you feed them. Good result only comes with good data. So the first lesson I have to learn is make sure you label your data correctly and train the model exactly where it needs to be improved. This is the most time-consuming part. It's highly labor-intensive, but also the most critical part. Second, make sure your hardware is fit for the task. In this project, everything was smooth at first until we hit a bottleneck, where we couldn't improve the accuracy of the model after 96%. And there was one specific issue that kept failing. We checked the data, we make sure everything is correct, and we fed the model accurate labeled, more and more accurate labeled data, and hopefully it will improve it. But unfortunately, after thousands of images training, it just stopped improving. At one point, we thought this AI model is simply not good enough for this task. But then we reached out to the AI company that built this program. They pointed out something very interesting, and we didn't really consider it in the very first place, which is the hardware part of your AI detection system. The camera we were using was perfect for human eyes. It's just like any standardized camera lens. It was not a telecentric lens. So think about standard camera lens. Object closer to the lens will appear larger. Object further away will appear smaller, right? It's perfect for human brain to receive that message. But AI models actually learn by analyzing pixels. If a standardized lens changes the pixel size of just a defect purely based on the depth of the part, then AI gets confused. It struggles to classify whether the anomaly is a real defect or just perspective distortion. You end up having to feed the model tens of thousands of images just to see it not improving and probably confusing it. I hope this story highlights one key takeaway is AI can be an incredible tool for quality engineers, not only if you leverage properly. Without the proper equipment or the proper data to train it, an AI model can just be as flawed as human detection. To wrap up, I want to leave the students and young professionals here in this room with a piece of advice. When you leave your college Formula SAE teams and step into a mass production environment, remember that the most valuable engineers aren't the ones who design a part that survives the race week. The most valuable engineers are the ones who design a process that can survive at least 5 to 10 years production run. So the key takeaways, the first one is design for manufacturing. Don't just design for performance. I know this is like the mindset of probably every single Formula SAE students. You always want to shave a few ounces here and there, right? Improve the performance by 10% here and there. Actually anticipate how the part will be cast, machined, and handled. Let's say a part on the production line equipment breaks, and you were given the task of fixing it, right? Designing a replacement part where every single tolerance is controlled to 1/1000th of an inch with 20 different radii will only cause more downtime and a longer manufacturing turnaround. Tighten the tolerances where only absolutely needed and use consistent standardized radii sizes to reduce machine time and cost. Second, embrace forensics. When something breaks, don't just replace it. Understand why it broke at the material level. Communicate with your stakeholder teams, let them know the risks, and work together to proactively fixing it. Trust me, no matter how busy you are, proactively fixing a failure point is always better than getting a phone call 3 a.m. says, oh, the part we replaced last week just broke again. And we didn't realize until 3,000 parts later. What should we do? Lastly, leverage the data. Be objective. In this line of work, you need to let the data talk. Use every tool available to pull accurate data out of your production line. Remember, quality control is not just one team's job, and is completely useless unless you have bulletproof data. You're not going to convince other teams, stakeholder teams, to make the necessary change unless you have bulletproof data. Remember, quality is no longer just the department says no at the end of the line. It is the core strategy that makes the entire operation possible. Now, thank you all for your time, and I'll be happy to open the floor for any questions.
On the AI, how is that impacting your staffing? Are you replacing people with AI, or how are you doing that?
Okay. I know this is going to be one of the questions. Because every time someone talk about AI, there seems like a trend going on in the internet, just like, oh, this is going to take the human job, right? I understand that. Like, think about the example I just gave. Yes, did it take someone's job? Yes. Someone was sitting at a computer, probably miserably, clicking 2 buttons every day. Do you think that's a human job? I don't think so, right? There's some jobs that meant for machine to handle much better than human. And I do think artificial intelligence can definitely help improving the overall process and improve your overall safety and quality of your product. In the process, like I mentioned, it takes a group of engineers to properly train the model, right? And it takes more engineers to train to actually build the AI model code line by line, right? And there has to be equipment engineers to make sure to facilitate, make sure we have the right equipment. In the process, you probably created way more jobs than actually taking the job that's never supposed to be handled by human. Hopefully that's a great answer.
What do you think are the major areas of companies or the department? Years campus. All you usually all the time.
Yeah, I do notice there's a yes. So the question is like, your name is Ken. Found that like a lot of the companies, when they're like having financial hardships or whatever, it seems like quality is almost the first thing to drop. And naturally, you would think this because they're cutting labor on quality or whatever. I would say that's probably half of the time that's true. And I would say a lot of people probably didn't know, like another 50% of the chance that's just because it's not because they're cutting quality engineers or quality technicians. It's because they're trying to cut down material cost, which is making a lot of changes, I should say, thinking they would save a few cents here, a few cents there. Eventually, that basically leads to, when they add up, it leads to bad quality. I want to say almost, and under any circumstance, quality is the first thing that gets impacted. But that's exactly why you need to have robust quality control process, right? So, for example, if a company wants to save costs on material, right? How do you prevent that switching to a slightly cheaper supplier for your material doesn't affect your overall production quality, right? Do regular checking, right? And make sure the product, the inboard parts are made to spec, meets all the material specifications. And that's exactly why quality control is even more important in like financial hardships. Does that make sense? Okay. Yes.
So is the current generation of engineers lacking folks in the use of
I would say almost yes. You know, the other day, Chief Fools was telling this story, like students in school these days almost have zero hands-on practice. They know how to handle CAD, but they don't know how the part is built, right? For manufacturing industry, this is a big red flag. I do want to say like Formula SAE probably is one of the last and probably the best projects you can get hands-on experience. I was just explaining to Long Beach team earlier. Like, don't think your hardships or challenges you face at your Formula SAE process is a bad thing. Like, there's a lot of teams out there, they don't have that experience. Their cars are built perfection probably by engineers several decades ago, and it's like built to perfection already. So you don't actually get to learn that. So use every opportunity in your school projects, such as the Formula SAE, and learn that why the part failed. Don't just replace it. do through root cause analysis, find out what's causing the failure, and document everything. I know that this is something like almost all the Formula SAE teams I know like is constantly lacking. They tell me, oh, unfortunately, there's no documentation for this. It was designed this way last year, so I don't really know why. This is the worst answer you can expect from Formula SAE team during tech inspection is, oh, I don't know why it's designed this way. And I don't know if it's gonna fail or not. All right. Mhm.
I think you mentioned what case in Tesla. Do you know if they did like a final review of like does using AI actually save money? Because I think a lot of times like all these corporations they just use it for the
Yes.
sake of like using it or like
For safe using, yes.
exactly like for like either the stock market or whatever.
All right.
Or, like do they actually do any analysis on like
Yes.
does it actually save money or is it like better off to use
So
regular pay?
yes. So the short answer is yes. So to kick off any project in Tesla, you have to do a very thorough study of your return of investment. In this case, investing the AI model costs compares to nothing if you consider paying someone sitting there every like 24-hour shift, paying benefits, and if you have a quality escape, meaning like someone misapproved a product that's causing defect, install it on the actual vehicle, get on the road, and you have a what we call a vehicle off-road type of situation, meaning the vehicle is not operable on the road. That cost adds up quickly compared to their initial cost of implementing a new camera system and the new AI model. That initial cost divided by the parts you produced and consider how much quality defect you saved is actually very, very easy to justify. The lady in the
If people have those, when they're either using the AI model or they're doing anything else and they're doing, you can fudge the numbers and not have them, right? So they might say like, this is a chill rock, right? You're doing them great, they're doing more. And then they would be able to use them and then use their defects. But they don't oftentimes talk about the cost of things. So when they have a engineer working with something that could have been done upstream, they don't often think of that into account. So when we're thinking about the process of that part, but then you think about like all the road numbers that go into it, meaning that you have less people to do more work now. That's something that I always found that we a little bit that they can forget that side of things. And too, the way you hear things with manufacturing, right? You talk about components and everything else. There's a very human side of things. So if you're a human factors, like what we had mentioned about going into a factory, you can think of all these interesting things about, oh, machine did it for this, the material, right? And when you go there, and you actually just find that like the guy at the end of the line keeps dropping something, and that's why you have a name in a particular place. Because there's like a little, I don't know, metal thing that's sticking out, and he's always dropping it in the same spot. Like you would never have been able to engineer it the way out of that, when you can go through the site and see stuff. So like my thing is, if you are in school and if you go and get an internship or get your first job, and they say, we're gonna send you to like, Timbuktu, just go. Like you will learn, I think, so much more, right? When you get on the faculty floor. And you'll see that even though we talk about robotics and talk about AI, there's a very human element where things have happened, and a lot of the failures, it's human failure.
Yes.
Like there's a reason why at certain times in Michigan,
Yes.
the parts, the defect rate goes up. And it's like, oh, it's the start of hunting season, or there was a Michigan game. Right?
Yes.
Like we joke about those
Yes.
things, but people get fired. And
Yes.
then they're looking at something that
Yes.
you see.
Yes.
Exactly. Yeah, right there.
Yeah, just to add to that, exactly. Like if you go to any OEMs, doesn't matter if you go to Ford, GM, Tesla, yeah, you go to any assembly line or components assembly line, right? Almost I can guarantee you, ask them what's your highest defect causing issue. Almost like I can guarantee you, almost all factory will tell you handling damage is the number one, or at least on the top 3 of your chart. So that just tell you there's a lot of human factor involved in the production line, and those things are extremely, extremely hard to control. You can train your human as many times as you want. I can tell you that same mistake will still eventually happen. And not because like I want to say they don't have adequate training or anything like that. It's just like it will naturally occur. That's the part, the hardest part in quality engineering. I would say is like things you cannot control. Like what I want to give one example is like when we're doing cooling tube assembly, like from different stations, the parts, the cooling tubes are transferred by these manually carts handled by human. And on those carts, they have sharp edges. And a lot of the time, you have a fault on the battery cell or on the cooling tube. It's not because like there's like particle from outside. It's actually like someone accidentally cut himself, didn't catch it, and the blood dropped on the cell or on the cooling tube. So those things are extremely, extremely hard to control. But I don't want to say automation is necessarily the only solution here. Because one thing probably everyone knows, like when Tesla first built their factory, they almost went too crazy on automation. They hope the whole factory just runs automatically by themselves. They don't think they need any human. I don't know if this is gonna get me in trouble, but there's this machine in the production line. That machine itself is almost 15 tons. It's a robot arm doing one simple job of rolling a tape on the back of the module to seal it. The tape has a very delicate wirings in there. Imagine you have a 15-ton arm doing that motion. It's a lot of pressure on the parts. And that's actually one of the highest reasons why that part keeps failing. It's just because too much pressure gets onto it. On the other side of the factory, they have exactly the same process, but completely done by human, right? And that line has almost zero defect because that's just a very simple rolling of a tape motion, and everybody can do it. So I want to say, like, hopefully also as to Steve's question, I do want to say over relying on automation or overly relying on human is not the perfect solution. Like I said, a lot of time you need to balance both. You need to know which one handles better and design your factory around that. Right.
Thank you so much, Joe.
Thank you.
You know, way more interesting than I ever talk about flawless. It's really cool. And so I think we're open. We can come until 8:30. So we about an hour to check out the museum, and I hope to catch everyone in a month for our July event on the hydrogen combustion. All right, thank you, everybody.